Today we are looking at MCP, the Model Context Protocol. You've probably heard a lot around it. It's all over the AI world and for good reasons. But instead of just repeating the hype, we are going to unpack it clearly. So let's break it down, the motivation behind it, how it works at a technical level, and where the ecosystem is moving. MCP stands for Model Context Protocol. It was introduced by Anthropic with its first release in November 2024, so the protocol recently celebrated its first birthday. Back then, Anthropic described it as a universal open standard for connecting AI systems with data sources, replacing fragmented integrations with a single protocol. In plain English, MCP is a standard way for AI models to talk to tools, apps, and data, so we don't have to reinvent the wheel every single time. You can think of it like the API standard for AI. Not just AI calling APIs, but AI natively integrating with external systems in a structured, predictable way. To see why MCP matters, let's zoom out for a second and look at the last few years of AI. In 2019, GPT-2 was released. It was the first glimpse that large language models could generate plausible, coherent text. Then came GPT-3 and other models. So models were getting even better with that. Well, and then ChatGPT launched in late 2022 and everything changed. It didn't just bring a model, it brought a universal conversational interface. Suddenly everyone was using AI. But very quickly we all realized chatting isn't enough. Early ChatGPT could write code, but not run it. Draft an email, but not send it. Summarize text, but not access files or store it. It had no context beyond the chat window. To solve this, companies started embedding LLMs inside their products, giving them access to real user data, real environments, and real actions. Instead of humans giving LLM context, the LLMs were embedded in the context. And that kicked off what I would call the agent wave. Models, planning, reasoning, and calling tools to take actions, not just generate text, images, or audios. But to execute these plans reliable, agents needed an entire support layer. State management, memory across multiple steps, access to context from the environment, and solid connections to external tools and data sources. So agent orchestration frameworks appeared. Things like LangGraph, Mastra, N8N, Cloudflare Agents SDK, and many others. And here's an important clarification. These frameworks are not alternatives to MCP. They help build and run agents, but agents still needed integrations. And that's where things broke down. At this point, many people asked, why couldn't we just use the existing APIs from those external tools? Well, because APIs were built for deterministic systems talking to deterministic systems. They expect exact schemas, exact fields, exact formats. Meanwhile, LLMs are probabilistic and free-form. As a rule of thumb, APIs expect perfect JSON, LLMs attempt JSON. So teams wrote endless glue code, schema fixers, response validators, and custom adapters just to make AI talk to those tools. As more agents appeared, the number of integrations exploded, also known as the end-to-end problem. So that means basically every agent team builds an own email integration, an own database connection, and also own integrations to internal tools. Basically meaning the number of agents multiplied by the number of external tools and data equals the number of connections. And this created problems around duplication of work, inconsistent formats, different auth models, different request response structures, and different ways to stream results. So there was no standard for tool and data definitions. And this is exactly where MCP comes in. MCP introduces a unified open standard for connecting agents to tools and data from non-deterministic applications. Let's have a look at the core components of MCP. MCP follows a client-server architecture. We have the host who is running the LLM, like for example Cursor or Cloud Code. The host has clients who manage a connection to a single server. And then we have the servers that are exposing the tools and data and prompts. So if we have a host connecting to a remote GitHub server, a remote linear server, and a data file system, that means the host has 3 MCP clients, each connecting to one server. The other part of MCP defines how messages are sent. And MCP separates 2 ideas. The first one is the format of the message, the data layer. And this layer handles the lifecycle management. It initializes the connection and the mediation capabilities, including the core primitives, which are the tools that are the actions the AI can execute, the resources are the contextual data the AI can read, and the prompts, which are reusable templates and instructions. MCP follows a predictable request-response structure. The message format is always JSON-RPC 2.0. Here is a simplified example of a tool request from the official MCP documentation. What we can see here is that the client sends a request for a tool called weather current and hands-in parameters. The server would then respond with a structure output, another JSON-RPC message, with the results. The data layer also supports notifications for real-time updates without requiring a response. The second part of the messages is the part that is transporting those messages. It handles things like connection establishment, message framing and encoding, streaming support for partial and long-running responses, authentication and authorization, including tokens, API keys, and OAuth, and the transport level error handling. MCP currently supports 2 transport mechanisms: standard input-output, which is used locally when client and server are on the same network. It is fast with no network overhead. And then there is streamable HTTP, used to connect for remote servers and support streaming responses. That are the main parts of MCP. Let's look into the further ecosystem. There are already clients that support MCP today. Different clients support different integration features of MCP, which you can see here on the clients table of the official MCP documentation. You can plug your MCP servers into tools like Claude Code, Cursor, and others. And on the right-hand side, there are already servers from tools like GitHub, Linear, Notion, and many others that are ready to integrate with the client's applications. And this is just part of the list from the official MCP documentation. There are many more. When it comes to building, there are SDKs for building MCP servers and clients in different programming languages. A lot comes from the community. And very handy if you build MCP servers, there is a tool called MCP Inspector. It is a web app that lets you explore, test, and debug MCP servers interactively, without the need to write any glue code or spin up an agent. It's a great way to validate that an MCP server exposes the right tools, resources, and prompts. It's a good way to get insights into an MCP server and can also help to debug them if you build your own. And the ecosystem is growing quickly. With things like ChatGPT's Apps SDK, many people are already imagining a future where everyday tasks, book a flight, paying bills, interacting with SaaS tools, or even managing your home happens through a conversational interface. So to recap, MCP is a model context protocol, an open standard for connecting AI to tools and data. It solves the end-to-end problem by standardizing the interface between agents and non-deterministic external systems. It defines a client-server architecture to keep things modular and secure. It always speaks JSON-RPC, and it sends those messages over transports like standard input-out or streamable HTTP. And it comes with an ecosystem, inspector tools, SDKs, and growing client and server support. And one last thought before we wrap up. It's true, part of the early buzz around MCP came because it gave traditional software companies an easy way to say, yes, we support AI. For many teams, building an MCP server was the fastest path to check the AI integration box without committing to a model, a framework, or a specific vendor ecosystem. But that's only the surface story. What's happening now is much more meaningful. MCP is no longer just an Anthropic initiative. It's becoming a collaborative ecosystem-level standard. Multi-major companies are now contributing to the protocol. The discussions are happening openly on GitHub. Of course, it's not without critique. Some say MCP is too cumbersome, too early, or just another standard nobody asked for. And fair enough, it's not a silver bullet yet. There are still challenges around context handling, token efficiency, and security. Whether MCP becomes a widely adopted standard or fades out will depend on how the broader AI ecosystem evolves. That said, despite the skepticism, we are already seeing structured momentum. Working groups are forming around specific domains. One example is the newly created MCP Financial Services Interest Group, which focuses on defining how MCP can work in a regulated finance environment. It's still early, but the fact that financial organizations and industry contributors are coming together around something this new is a strong signal. The ecosystem isn't just experimenting with MCP, it's starting to align around it. So, to wrap up my thoughts, MCP isn't just a temporary hype cycle. It's a serious attempt to standardize how AI systems interact with tools, services, and real-world data. It gives developers a consistent protocol, predictable message formats, and a growing ecosystem of compatible clients and servers. Whether you are building AI agents, you are using AI tools that should integrate with external tools, or you are building external tools that should integrate with AI agents, MCP gives you a foundation that scales beyond one model, one platform, or one vendor. If the space continues evolving the way it's moving now, MCP might become one of the core building blocks in the emerging AI stack.